From now on, we're going to meet on the third Tuesday of every month. So if you can make it and you want to learn more about F# after what you see today, or you already use F# and you want to talk to other people that are using the language, come check our group out. We've got quite a few smart people that are coming, and also a lot of beginners. So we're having about every 3 months an introductory talk, and then the rest of it is sort of skill building and discussion about projects we're working on. But I know you're all here today to see Don, so without further ado, Don Syme.
So it's a total pleasure to be here in New York. This is sort of an add-on couple of days. I was thinking I might just come to New York and chill out and sort of enjoy the Central Park and all the things here. But of course, I had to come by the user group here. I've been watching from afar on from the London user group. I think you guys have beaten the London user group tonight for the size of gathering. So congratulations on that. That's Rick and the rest of the people who've been organising. That's an absolutely fantastic turnout here tonight. Thanks everyone for coming. I thought I'd actually begin with looking at a statistic about the F# community. Make sure you are here. And what a wonderful community. This is the stats on Stack Overflow for the proportion of answered questions versus unanswered questions here. So just under 1% of F# questions are unanswered on Stack Overflow. There are about, I think, 10 or 20 very prolific answers of questions. I think the quality of answers are absolutely fantastic for people. When people seek help on that site, it is, I think, the primary place for seeking help now on F# questions. So that really is a great community effort at broadening out the technical knowledge in the community. Okay, so today this is sort of the material I've been presenting yesterday at TechEd in Atlanta, and it's a talk of two halves. It's a little taste of F# 2.0 as it is today, how it's actually being used in practice, what we see it actually being for. Why is Microsoft doing F#? Why is it adding a functional language to Visual Studio? And I think then I'll also be talking about the topic which is really driving me. This will be the second half of the talk. The second half of the talk is what I'm talking about here, which is the work that we're looking at adding to the next version of F#, and which I've been working a lot on at the moment. And so I'm going to talk about these additions initially. I'll come back to for the second half of the talk. I just want to get across the idea of what we're doing with the language. Before we start, can I just put up how many people are completely new to F# in the audience here tonight? Oh, that's quite a big ratio. And how many people are using F# pretty regularly in their day-to-day? Okay, that's great. Okay. So what we're adding to the language is, I think, one of the most exciting and relevant sort of developments in programming languages in the last 5 or 10 years. It's very exciting and very relevant to the sort of data and service connection problems that are fundamental to so many parts of programming today. And that is because the world is, we've seen these enormous themes running through the industry of the web and of multi-core programming over the last 5 or 10 years. And now the big dominant issue is to do with data and coping with absolutely massive amounts of data. And I think what we're doing in the next version of F# is combining the functional programming that we've focused on in F# 2.0 with a sense of information richness. Something I've really been learning is that functional programming is such an awesome type of functional programming is such an awesome paradigm for tackling the complexity of working with information. But traditionally, if you look at the type of functional programming languages, they have been not information-rich languages, in the sense that it's often, you look at samples in functional programming languages, the classic ones being Project Euler samples, absolutely lovely to work, to learn to do core functional programming, but all the information is internal to the problem. It's things like find the 10,000th prime number or something. There's an internally generated information. There's no information flowing in from the outside. And the functional programming languages, type functional programming languages, have traditionally been poor at acquiring information, getting information under the type discipline. Once you have the information under the type discipline of these languages, you fly. It's like you're just zipping along with your programming, and your bug rate tends to be low. We can talk about that later. But it's that bridging that gap between you and the outside world, the sea of information, the oceans of information that are out there, that is what we're trying to tackle in this part, in what we're adding to the next version of F#. So the world is incredibly information rich. We experience that every single day on the internet. We use Wikipedia, we use Google, we experience it all the time in our enterprise programming context. We experience on our phone context that when we're programming for these devices, we are building applications like a traffic application that might be combining multiple information sources, and applications being entirely built around information sources today. But our languages and our frameworks are in many ways information sparse. When you look at the .NET framework or the Java kind of frameworks, you don't find any actual information. You find lots of gadgets for manipulating information. You find your XMLs and your strings and your byte arrays and your streams and this sort of very generic kind of gadgets. But you don't find a definition of a football player or a chemical element or an oil field or any of these other elements of information that you do need to actually work with when you're building actual applications. So that bridging to the real information is a real problem. And the future of F# is about opening up the language to a kind of information richness which we haven't been able to achieve before. And we'll be using a sort of kind of magic. It can seem very magical what we're adding to the language. It's really a change in compiler architecture and language architecture, tooling architecture. And that's called F# type providers. And how many people here know what link is? Yes, correct. So when you take link as some sort of language integrated query story plus type providers, you can think of these as two very complementary things. One is a mechanism for querying objects, iQueryables, once you have the information source in a strongly typed way, and the other is actually getting a lot of those iQueryables in your hands to work with as you need them. And you can kind of think of that as a language integrated data and services. But the first half of the talk is about F# and give you a taste of it and why should you care about the language. It ships with Visual Studio 2010. It's in the box for how many people here use Visual Studio 2010? Okay, great. So it's right there. You can use it even if you're using C# programming or Visual Basic programming, or you're quite able to just click on New Script and add an F# script to your project. And you can use F# scripting as part of your regular work for, say, testing your DLLs or some other part of working with information in addition to, say, the C# and Visual Basic programming you might already be doing. So when we describe the language, we did this little this sort of mission statement for what F# 2.0 is all about. As F# 2.0 is the one in Visual Studio 2010. We shrink it down, and then we realize that we keep leaving off all these absolutely critical adjectives, and we start piling the adjectives back on, so it kind of shrinks and grows depending on the particular talk I'm giving. So so recently, I've added in these things that people can really miss about F#, right? We talk to people and we've realized that for the last 5 or 10 talks we haven't mentioned that it's actually in Visual Studio 2010, and people might leave with the impression that it's just like a toy or something. And that, it is supported by Microsoft, 10-year support guarantee when you buy Visual Studio 2010. And then this is the adjective I added just yesterday, because people can really leave these talks without realizing just how amazingly interoperable the language is, both at consuming .NET libraries. I mean, the interoperability through to the .NET libraries is just absolutely, nearly entirely seamless, and in fact, some of the idioms of .NET, like events, for example, get exposed in F# in better ways than in C# and Visual Basic. And so the interoperability through to C# and Visual Basic is absolutely fantastic, and the interoperability from C# and Visual Basic to F# code is also extremely smooth. You can, any of the F# code you compile, you can use directly from C# or Visual Basic. You can just create, we often see people who have C#, 20 C# projects in their team, and then maybe 1 or 2 F# projects in the middle of that, of say the user interfaces might be all in C# and maybe some database access, because you tend to do something like that in C# based on F# 2.0. And then the computational engine of some kind, the analytical engine that underlies the application, may well be in F#. And the interoperability is extremely smooth. We use it all the time in the F# Visual Studio implementation. Most of it is in F#, and some parts are in Visual Basic because the property pages are in Visual Basic, and some underlying components are in C# because when we started, we had to port some initial implementation of the project system over. And you don't even think about that as being an interoperability barrier in any way. You really can have 1 or 2 or 3 or 10, however many projects in F#, but it will not be a problem for your overall architecture. Okay, so productive, supported, interoperable, functional programming language, and then the real mission statement here for the F# team: simple code to solve complex problems. The role, if we look at the programming language spectrum, we really want to give a power tool for these information workers, a strongly typed power tool for the people writing these analytical engines, to help them crack the core complexity of an application. And I really think we've succeeded in bringing that tool in Visual Studio 2010. So what do I mean by simple code and strongly typed? People who've seen my talks before will have seen some of these samples that I showed. We take some, it's a very easy game to play. It's almost like, what are those shooting things in a barrel, shooting fish in a barrel here. You just take some design pattern in object-oriented programming and you translate it into functional programming, and then you compare it to the object-oriented way of doing things. And you here have the command pattern. You go back to the 1990s book, and you want to model the notion of a command in some sort of simulation engine. Okay, this simulation engine is going to take where commands are going to be there. Actually, they're going to mutate the rover in some way. So it's following the design, is faithful to the object-oriented design pattern in that way. And you have a command as a function. A command is a function which takes a simulation object, a rover here, and does something to it. And then we have 2 commands: a break command, which accelerates backwards, and a turn left command, which it rotates left by -5 degrees. And then you go and look at the object-oriented equivalent to this. It's the C# syntax. You could do this using C# delegates, because C# does have a functional programming subset, and that's good. That's how I prefer you do it. But this, if you go and sort of do the Java kind of gang of 4 design pattern object-oriented code explosion sort of thing, then you start with your hierarchical modeling, and you get out your big book on object-oriented hierarchical modeling, and you have to start to think. I don't really understand why people say object-oriented as functional programming is complicated, because what's really complicated is to have to start to model things by command, and then you have a rover command, which subsets this command and has a rover field and takes a rover and puts it in the rover, and then the break command here, which takes the rover and puts it in the rover again, and then finally you get a little bit of logic somewhere down here, and then it goes on to your next command and so on.
No units in C#. If you make it with
yes, and just tucked inside. This is the first person that ever brought that up on this slide. this actually has this -5 degrees here using units of measure somewhere in F#, and this one doesn't here. Similarly, you just take some functional programming samples, just this bread and butter of working with information in a strong type functional language, where you have, say, swapping the elements of a tuple or taking the rotations of a tuple. And this might be used, for instance, in test case generation. You might be, you want to test some engine you have on, you have your inputs, and you start to commute the inputs, and then you start to commute the other inputs, and you take the combinatorial explosion of the combination of those, and then you start to take random sampling of those and give it across to the test, to the engine. And so fairly straightforward programming. And similarly, you might have a reduced function which takes f and applies 3 elements of a vector and applies, or a tuple, and applies them to each one and adds them up. And it's all straightforward and declarative. And then you go and write that in sort of thing in C#, which, I mean, I worked on C# generics. It's a lovely language, and it is, you know, the system of generics is extremely nice, and the design patterns they use for the object-oriented libraries are extremely nice. A lot of good, and Link is excellent, and there are lots of good things about C#. But for this kind of work, things tend to kind of explode. This isn't exactly how the F# code compiles, but it's sort of, it's one rendition. It's hard to get particularly better renditions of how you write this in C#. You can see this swap function. You just wouldn't end up writing this stuff because it's so horrible. You just would never do this kind of functional abstraction, and never work and think about information in the way that you're thinking on the left here. Okay, so this can get quite extreme. I'll show a video which I don't always show. It's an old video. And it's an interesting one. I have to. It's quite quick as it goes through, and I don't know if I can plug in the audio here. I think I won't try. It's actually got this sort of Looney Tunes cartoon music that goes along with it, so you can. I'll turn it up and maybe you can get a test of that. So let's run back to the start here. Okay, so what's happening here? From F# to fxcop. So this was done by Lucian Wiszczyk on who's now on the Visual Basic team, but he loves F#, and he's always very kind in his talks where he asks how many people in his Visual Basic audience have used F#, and a small portion of the Visual Basic guys and girls hold up their hands, and he says, no, that's not enough. You should all be we want to come back next year and have many more people with their hands up. And right, so he took a program here. Let it test, return some data, a tuple again. I normally put the parentheses in here. It's returning a list, a tag list, and an x and a y coordinate for the tags at the given coordinate. Fairly straightforward bit of information representation there. Generate some basic data, which again we might use for testing or the like. And he then does the translation into C#, and then perhaps there's various ways you can translate this into C#, and you can start to argue about which way you might do it. And then he applies this fxcop tool to the translation. And the fxcop is a great thing, right? It actually does give wonderful consistency to the .NET framework, and it's the right tool to use in many circumstances. But in this case, it's sort of questionable. So let's start to see where things lead. All right, so this is the start. This is C# encoding. So he wants to return a struct which contains the x and the y coordinates and the list of strings for the tags. And he has this static public tag point test, and he creates a tag point. He assigns mutably, assigns into the x and y coordinates there, and the tags here, and he adds into the tags the hello and the world, and he returns his tag point. Okay, and then runs fxcop. And the main problem here is the struct, because fxcop likes structs to have a sort of equality semantics, and it wants to have an equals method on the struct type. And because it turns out that the default one you get by inheritance from system.valueType is actually really slow, so it's probably better in a framework setting that you actually go and implement that equals method. And then if you have an equals method on something, it actually wants to have the equals and not equals operators on that type as well. And if you have an equals method, well, you better have a get hashcode method. Because, you know, there's lots of data structures that like to have equality hashing pairs. And so that then goes through this. Okay, so whoa, okay, so equals and equals and not equals and get hash code. And it's actually probably not a very good hash code function behind here, which we could talk about. Just like XORing the hash codes isn't really the best thing to do. And we continue on. Right, so now you're being told to make tags XY private or internal and provide a public or protected property to access them. So there we go, we better do that. Now we correct the casing of the XY tags and tests because it's lowercase. And critical warning, consider providing a more meaningful name than the one-letter token X and Y. Okay, and
Can you turn the font size up a little?
What's that? Yeah, change tags to be read-only by removing the property setter, and change list string to collection of string or read-only collection or key collection. And there we think that's where we have it. Yeah. Okay. Now this has been hanging. This video has been hanging around on the Microsoft internal network for a very long time, and it's been interesting to every now and then I get some irate email from someone telling me how useful fxcopy is for, and I do understand that fxcopy is extremely useful in shipping frameworks. So don't get me wrong, I'm not actually having a go at fxcopy. I defend its role in the shipping frameworks and to the death, yeah. Because the .NET frameworks are absolutely wonderful, and it's partly because of that tool. But you can see the kind of problems. We're working in a different kind of programming space initially, and we're taken off into a sort of object-oriented framework development space. And it's a different kind of information worker role. It's a different kind of jobs. Yeah. So there's a core of type functional programming which is about addressing that problem. Just giving you a powerful framework for manipulating core shaped information. Okay, type functional programming is all about having shapes of information and having the types represent those shapes of information, and then do your transformations on that shaped information, lists of tuples and strings and so on, and then do correct transformations as you produce the output from your functional programming code. But there are other that's always been a core part of programming, and there are other very big trends going through the industry that we're also trying to address with F#. One is the web, now the cloud, and the other is multi-core programming. And asynchronous programming in F#. There's about 3 entry points to parallel programming in F#. One is there's array.parallel.map, for example. Array.parallel.map, which just does straightforward parallel map over arrays, and then you can do parallel iteration and parallel choosing and filtering and a bunch of other parallel array operations. That's very much focused only on multi-core programming. I think there sometimes has been overemphasis on multi-core programming in the last 5 years at the expense of the importance of I/O, asynchronous or parallel I/O or overlapped I/O programming. When you look at modern server-side programming, it's very often about getting scalability to be handling tens of thousands, thousands or tens of thousands or 50,000 simultaneous requests from single servers. And that necessarily involves asynchronous programming and overlapped I/O programming. So F# has this very, very nice model of asynchronous programming where you can do, for instance, parallel, this is a fork join composition of, say, 3 or 10 or 1,000 simultaneous fetches of web pages, and that was shoot off the request simultaneously. It may go through various queues along the way, and then as the results come back, then eventually the fork join will continue on with some continuation. It's effectively a form of continuation-based programming. It's compositional in the sense that you put a composition together, and then sooner or later on the outside you kind of press run. You pipe this into the run synchronously function in some way. You run the composition of asynchronous and parallel. Then you run them, and that will be run again this will be run using the multiple cores of your machine. I'll talk a little bit more about the asynchronous programming later. It is an important skill to develop as part of your F# programming if you're doing any I/O programming. And I'm sure Rick will be glad to hold several future skill learning sessions on focusing on asynchronous and parallel programming. But one of the very nice things about the asynchronous and parallel support in F# 2.0 is that it actually speaks to both of these things in programming. It is about a highly connected programming, highly I/O-bound programming, and often today you get a mixture of I/O-bound programming combined with CPU-bound programming and also latency-bound problems. And the asynchronous mechanisms that we have speak to all three of those problems. Okay. So let's have a look at a taste of using F# in Visual Studio 2010. This sample is actually just programming with event streams. Yeah. Sharp script here called Twitter feed, and we have the normal F# interactive window, and I'm pretty sure most of you know how to find that under the view F# interactive, or if you're working in the C# and Visual Basic modes, you can find it under other windows here. And I can just I'll highlight the text and then hit Alt-Enter and then execute it in the session below. So I loaded up 3 helper scripts here, a password script as well for my Twitter password, and a small object-oriented one class definition which defines a Twitter stream, which sits over the publicly available subset of tweets coming from the Twitter service. So let's first show some data. For example, show the numbers from 0 to 99. And that we'll call so we take the number 0 to 99 here, and we call the show function, which takes that data and shows it in the window over on the right. So it shows some other data, for example, that tag list that we saw earlier. 12, 3. Raise that up there. And so sometimes you'll see me use the piping operator. So if we create the numbers from 0 to 99 again. And we pipe it into the show function here. That's just simply reverse function application. This is where you take some data and you put it into a function on the right. You'll also see us build up pipelines of sequences of transformations, so that we may take those numbers from 0 to 99 and then we'll start to transform those. So we'll take that list and we'll take each element of the list. Here we've got some number x, and then we'll return x, a tuple of x and x times x. Now, functional abstraction is a key part of F#, so it'll be very common for people to be writing, say, a square function, x times x here, and then one square of x here, one cube of x here. Find the 2 functions. So by default, arithmetic works over integers in F#, 32-bit integers. If you want this to work over floating point numbers, you put a floating point annotation, type annotation on the variable here. For example. And then you'll get a type error here saying the input here was an integer, that this was a list of integers, but we expect a list of floating point number at this point. So you'll get that type error. So let's start moving towards more reactive and event-based programming. So let's create ourselves a form. And I'll set the visible equals true and the topmost equals true, just to have it always sitting on top. And let's now F-sharp does F-sharp certainly uses mutation at certain points in the design of a system. It's very common that the user interface state of the system is mutable, can be changed. So we can change part of the user interface state by using this left arrow assignment to set the text on the form over on the right. And the next thing we'll do is do a very typical mixture of imperative and functional programming, where we add an event handler to the form, so that each time a click happens on the form, we're going to show the coordinates where the click happened. So we're going to get the mouse click event. We're going to take that event and add in a handler, where we get the event args for the click. And we're going to show the event args of X and the event args. So we add that handler in. Now each click we do, here, you can see the results coming out over on the right. Now, because this is the clicks is a stream of events coming through the system, we can start thinking about more functional interpretations of that stream of events, and that we can transform that stream as the event stream progresses. So let's throw that form away, create ourselves here, create ourselves a new one, set the text again, and we'll take the event stream here, and we'll map over that event stream so that each time we get an event, here, the event args, we transform it, we select out the X and the Y from the event args, and then we do an event.add to the show function, and that will give us the same result we had before. Except in between, well, let's put a filter in here, which selects only certain events. So we want the events where the X is greater than 100. Now we'll add that pipeline of transformations to the click stream. And now as we click, then when we click over here, we get results. But when we click over on the left, we don't get any clicks coming through, because we've selected out a subset of the events coming through the system. Now let's apply that same kind of thinking to working with the stream of tweets coming from Twitter. So the first thing we do is we take that stream, and we're listening to the network here, and this is the JSON text for each of the tweets coming from the service. I think it's a subset of about 1 in every 100 tweets, 1 in every 200 tweets or so tend to be given through this particular subset that Twitter makes available. Forgive me if some things appear in the text that probably wouldn't normally be shown in the talk. That text isn't entirely under my control. So that, because that has happened to me, especially in a talk I gave in Sweden, where I now put this little show waiting for the next tweet stream, just so I don't interrupt it at some point where it shouldn't be interrupted. There was some, if you look at the video for the Tech Days talk I gave in Sweden about a month ago, there was some very fast keyboard work to try and hide what was on the screen. Now, let's construct a pipeline to transform. So we've got these tweets coming through the system. Let's construct a pipeline to do something different with those tweets. So first of all, we'll map a parsing function over the tweet. So in one of the earlier scripts, I defined a function parse tweet, which takes a string and does this business, which we'll be talking about more later in the talk, about getting a strongly typed version of that data. And it may actually fail. There's for some reason parsing some of these tweets does fail. So we don't like nulls in F#, so we use this option type to represent a potential failure. So we'll get none or some coming through the system. And so we add the parsing into the transformation, and we have that appearing over on the right. That's beginning to look a little bit friendlier. I'll move this over so we can see the data now. So we can start to see the username and the number of friends that they have, and how many followers they have, and when they joined Twitter, and when was their last status update, and what did they actually write in their status update. So I hope all of you are busy thinking about all the great ways you might be able to use this information, because all the number of machine learning techniques that you can start to apply, or statistical analyses, or websites that you can build that transform this information in some way. So what we're going to do is just look at the words, just do a bit of textual analysis about what words are coming through. So in order to get the words, we need to start splitting strings apart. So we just use the .NET object-oriented string.split. It's quite a nice function. You give the characters to split the strings, and you also give this option, string.split options.remove empty entries, and we can just check if that works here. So on all pretty horses here, and we split that apart, and we see what result we've got over on the top. Now, if you were working in F#, you might not have one of these windows available. You could just execute like this and check down below that the results are okay. And then you would start to iterate this through to become a proper test case, and eventually iterate through those test cases to become proper unit tests for your code. So now we can choose the successful tweets. Choose is just like map, except it throws away the operations that don't succeed, that don't return a sum in a value from this option type I was talking about. And then for each tweet that we successfully parse, we get the words out of the status field here. And we show those. So there are the words coming through. Good. And so now let's just build a larger pipeline of events. So we have of event processing. We have the parsing of the tweets. We map the words out of the status field. And now we have one of these lovely magical combinators of building up an incremental histogram. So this histogram one keeps is a scan of the event stream. So it keeps a little bit of state as the events go through, which every time an event comes in, it then runs a function which updates that state, updates a map containing an index of the words, count the different words, and then every 10, we throw away the histogram 9 times out of 10, and every 10th histogram we grab that, and we take the top 50 entries of that histogram, and we show it over on the right. Let's go through that. Okay, so now we can look at the words coming through. We can see that it's definitely Twitter, because we have RT up the top, which is retweet. Is the most popular word on Twitter. We can start to look at the languages being used. Obviously, we have Spanish and other languages here, and it's quite a lot of English words, quite a lot of symbols being used. And this is where I first discovered the word Bieber. That's my favorite Justin Bieber jokes. I was actually wondering why were the Germans so concerned about beavers that was coming through Twitter, and I learned something about teenage culture. Okay, so sometimes you do get very topical things coming up. I'm not sure if there's anything particular. We've probably just got into the generic words by this time. Okay. Okay, so I hope that gives you a feel for doing some interactive scripting in F#, F# 2.0. I do want to emphasize at this point that F# is a strongly typed language. You can have a project in Visual Studio. You can have F5 build, build and debug and breakpoints, and you can compile to a .NET DLL or to a .NET EXE. That just because in these talks I tend to use the interactive scripting but I think that doesn't mean that I think in practice people tend to use it mostly in the project-oriented mode of the language and compiling actual .NET binaries. Okay, so let's talk about what F-sharp's role is amongst the languages on the .NET platform. And this is absolutely crucial because we don't... F-sharp has some very nice features, it's a very nice language, but it has to have a sort of a niche in the platform. It has to have a role. It has to be for something in particular. And we had a pretty clear idea of what we were doing with F-sharp 2.0, but we have taken some time in the last 6 months to step back and look at, well, what are people actually using the language for? Where is its niche? Where is it really giving the 3x or 5x productivity benefits that we hear about anecdotally from customers all the time? But what's the common theme amongst these? Okay, and it's very tempting at Microsoft to try and tie yourself to what we'd call a vertical. Okay, the finance industry, for example. Obviously, there are some people here using F-sharp in finance. But that doesn't seem to do justice to what F-sharp's actually good at. It's not good at all financial programming, necessarily. It doesn't excel at all financial programming, but it also excels at other kinds of programming as well. And then you can start to spread yourself too thin. You can start to say, okay, we're going to try and do bits and pieces of everything. And it's very easy these days to spread yourself very thin indeed, especially when you're working at Microsoft, because the Microsoft view of the computing industry is enormous. We touch every single part of the computer industry, from Xbox games through to device, low-level embedded systems and device drivers, through to financial programming, through to web-based programming, and it just goes on and on and on. There's so many different parts of the programming spectrum. So as we looked at this, the common theme which we really liked was about analytical engines. Okay, and this is generally server-side programming, but sometimes client-side. And so a good example is the Path of Go is a game written with a machine learning engine. It's a Go game, but the AI engine is a machine learning engine written in F-sharp, and it's shipped on Xbox Live Arcade. And now, as they take that core AI engine, and for instance, if they think about doing a phone version of that game, then you have an analytical engine, okay, and it's one of these projects which has F-sharp at its core. The whole rationale for that game is its AI engine, okay. That's why the game exists. Now, it might be that that's only 2 projects out of 15 or 20 projects in the overall system, or whatever is the balance. The reason the game exists is the AI engine. And that engine has to be able to run both on the client side, in the phone, for example, in a phone version of that game. It also has to be able to run on the server side, on the cloud, okay, because you might have an option where as you move to a more advanced level of the game, then the AI switches and runs in the server instead of on the local client machine. So just because you're doing analytical engine programming doesn't mean it's all server-side programming. Though I think F-sharp's natural strength is towards the server-side or core computational components of client-side programming. So some examples of this. This lovely example of the use of F-sharp by Simon Cousins at Eon PowerGen. So this is an analytical engine for balancing the national power generation schedule in the UK for Eon PowerGen. And my understanding, I don't fully understand the domain, but they're getting all sorts of signals coming in about power production and power requirements. Some of those signals are more reliable than others, and they have to have an engine which makes sensible decisions about how much power to be ramping up and producing. Simon did give a talk at the London user group about some of the ways that these signals come into the system. It turns out that the Finns publish their power import and export statistics on a website, which is a map of Finland with little boxes in them with bitmaps which contain the numbers of how much data is coming in and out. And you actually have to kind of go and screen scrape that code screen scrape those web pages, those images, to extract the actual numbers and then feed them into as one of the signals coming into the system. Which shows, of course, that data acquisition and import is a key part of writing these engines, and sometimes it's not as clean and nice as we would want it to be. Now, the calculation engine for this is written in F#, and Simon has written very nice descriptions of the role that F# played and why it was just such a beautiful language to address this particular problem. That write-up is available in the it's linked to in the F# 2.0 in the Enterprise white paper that we put out about 3 months ago. That's available from the fsharp.net site, and I'd encourage you. It's quite a short little white paper, but it's got some very good links to case studies and the like. And the fsharp.net is one of the Microsoft sites for F#. And he draws out in that all the elements of F# that made it so successful. One thing he argues quite convincingly is why those added up to have such a low error rate in their code. When you think about the Twitter example that I showed, we were able to compose those elements without really there being any chance of being a bug in the composition of that pipeline. If the histogram function that I'd used, which is actually quite a simple little function, had bugs, well, okay, maybe there would have been, if one of the components had bugs, then maybe we would have had a bug. But this key thing about type functional programming is building correct programs out of correct building blocks. Okay, and it's the fact that those building blocks that we used were all correct, without any danger, without any doubt, they weren't going to give us a problem. We were able to build this correct pipeline, which did something which, in a traditional object-oriented technique, build a histogram of the words coming from the Twitter stream and show it interactively and drop every 9th one and so on, only show every 10th one, and those elements. That could be many, many places where bugs could have been introduced into a traditional object-oriented solution of that problem. So Simon argues very convincingly that about the low bug rate that he experienced in this. He shipped the component, and he had to actually phone up the team he shipped it to discover if they were using it, because they hadn't reported back any bugs to him, and they said, yes, we're using it, it's all going fine. And there's no bugs along the way. And he said that's unheard of in that industry, to have such a low error rate for this kind of component. There are a couple of examples from finance companies here. Some of you work for some of these companies, one of which is anonymous here in this write-up down here. Big users of F#, and this Grange Insurance write-up as well. There's nice case studies available from the Microsoft side. Another one I like is the Darren Platt's use of F# at Amyris Biotech. Amyris Biotech is a startup in California for biodiesel based on genetically modified algae, and he is absolutely loving the use of F#. It's an ideal kind of use of F#. I think it's a replacement for Python in this context. Phenomenally useful. We'll be writing a lot of this in Python. Otherwise, F# is more robust, 20 to 100 times faster to run and faster to develop. And these statistics, those performance statistics for raw F# code, not factoring out the libraries. Okay, the performance statistic here doesn't surprise me at all for the difference between a strongly typed language and a dynamically typed language. Okay, and the faster to develop, I can also, I'm impressed, I'm very, very glad that Darren says that, because he is a very good Python programmer. He's one of the first people to show me Python. And Python is a great language. People are very effective with it. And to have someone experienced in the use of Python say that about F# makes me very happy indeed. Okay. Right here. So some basics of F-sharp. You would have seen already that F-sharp is a indentation-aware language. I just always run through these basic slides so that people understand what they're getting themselves into before they start using the language. That this is a badly formatted F-sharp program. You have to line things up like this to get to keep the language happy. That is an F-sharp application. You can compile that application to an exe, like shown on the right. fsc.exe is available from the Visual Studio command prompt. Of course, you can also pop it into a Visual Studio new F-sharp project, and press compile, and then it will work. That's a larger application. You've seen some of these examples. If you're compiling this as an application, you'd need application.run on the form down here. You've seen pipelines here. We often use the stages of pipelines, which you've already seen. A little taste of object-oriented programming in F-sharp. We tend to spend our F-sharp talks having a go, take some cheap shots at object-oriented programming, and then we show how nice object-oriented programming can be in F-sharp. This is probably a little bit unfair. But this is implicitly defining a constructor for an object. The syntax at the top, it's a class type, effectively. And the constructor takes 2 arguments, and this is so they're the sort of inputs. And I often think of it as a shape as well. There's data flowing in, there's some internal state, which is transforming that data in some way, and then this is publishing the data through the members. The members make up the API of the type. So they're the object internals there, and here are the exported properties. So this is where we're pre-computing, we're storing it. So these become fields here, if you want to know how it's compiled. This becomes a field as well. It's computed as you construct the object, and then here's the publication of the properties. And the method down below is scale vector here. Okay, just to mention that F-sharp has this asynchronous programming story. I touched on the parallel programming part of this. You also have these asynchronous workflows where you can have an asynchronous event on the right, and you can do an await for that event. And then the rest of the workflow is stored as a continuation, waiting for the completion of that event. So it lets you do lightweight reactions. It doesn't block a thread. It keeps the rest of the workflow as the continuation, as a registered continuation, rather than blocking a .NET thread. So it lets you react to GUI events, or timer callbacks, or query responses, or HTTP responses, or web service responses, or disk completions, or agents reacting to messages. So F-sharp asynchronous programming is actually being, a version of this, actually sort of a lower level version of this is being adopted by C# and Visual Basic. They will use the keyword await, where we use this let bang. This syntax can be reused in other ways as well in F-sharp, which is why we use a more generic term here. This is being added to C# 5.0. As I said, it's a lower level version, and you'll notice it's lower level in particularly in the plumbing of cancellation tokens. When you start one of these, you can give it a cancellation token so that you can press cancel on that, and then the async workflow will, at some point, it will check for cancellation signals and stop. In C# you have to plumb those cancellation tokens through explicitly. In F# they're threaded through the computation implicitly, and the cancellation checks are implicit as well. And I think that's a good thing that we're making those implicit but it does mean make it a bit higher level, and I think than the C# version. Once you have this lovely combination of asynchronous and parallel and immutable functional programming, that can take you in a number of different directions. It can take you to parallel multi-core programming. It can take you to server-side programming, scalable server-side programming, or it can take you to agent-based programming. And this one sort of language mechanism lets us address each of these areas quite nicely. So on the scalable server-side programming, imagine you had to write a server program which was going to handle 50 simultaneous TCP connections. They might represent chat sessions, for example. And you want to serve those with 10 threads. Now, the chat signals aren't coming in very often. People don't type in chat signals that often. Actually, this sample is actually writing is a quote server. So imagine you have 50,000 connected, and you want to start sending quote signals back to the clients down the TCP sockets. So each time you create an async TCP server, which is in the F# power pack, and you create a loopback, and you get the port number, and you say each time the signal. I missed the part. Each time a request comes in, this is the workflow that gets run to handle the request. So we get the stream to write back to here. The use just means we'll close the stream after the work is done. And then we write a header back down the stream, and then we write a quote, and then we sleep, and we wait for the next quote. And because we're using these asynchronous workflows, this scales to many thousands of simultaneous connections, where threaded-based programming would not scale. Okay, so in the last half of the talk, in the last 20 minutes, we'll be looking at this F# futures and information-rich programming. So what are we adding to future versions of F#? So there's no CTP of this available. We're sort of deliberately just talking to people about it at the moment. F# comes from, I work at Microsoft Research, and we tend to, instead of holding back the feature and then make a big splash about it when we release it, we tend to like to talk to people about what we're doing and collect information about whether we're landing in the right kind of space. And rather than sort of, we're not yet rushing out with giving you the bits to use to build your own F# type providers. Okay, so imagine we talked about information richness before, and imagine you in your favorite strongly typed language, C#, F# 2.0, or Visual Basic. Your job is to create a chemical elements class library and to populate that with data for the chemical elements. And how long is that going to take you to write that class library? Right? Week, 2 weeks at the back, yeah, to decide on the design and to document the properties. I mean, and to start to download the data and populate it, and yeah, it's a pretty straightforward contracting job, but it's going to take a while. So let's try and think about what. So the problem there is that your language is not an information-rich language. So now let's have a think about what would programming be like if our language were an information-rich language, sort of to start with. Well, not quite to start with. What we're going to do is reference a provider component, which is providing information to the programming context. So sort of adding to our language an information source. And now, we're all used to the idea of a library, a .NET library, Java library, which contains a fixed number of classes, a fixed number of types. You can go to ILDASM, you can go to Reflector, you can open those libraries up, and you can see the types that are defined in them. What we're doing here is, instead of just providing a library, plugging in libraries into the language, we're plugging in computed spaces of types, generated spaces of types. Okay? So instead of being a fixed number of types, there may be a computed number of types, and those types might be computed from some backing data store. It might be computed from a web service. It might be computed, in this case, from an ontology, a semantic web ontology. It might be computed from a database. It might be computed from a SharePoint server. It might be computed from local information on your machine. It could even be computed from a spreadsheet, some other application you're hosted against. And it's very much about it's a notion of hosted programming. And one of the big differences why this is becoming more important today is that our lives today, our programming lives, are always hosted against the internet or against our enterprise network. And so all our programs are hosted in some sense against a set of information sources, often which those information sources are often more stable than the programs we're actually writing. So this provider component, this is a small DLL, and but it doesn't contain many type definitions, but it's going to provide us with about 50,000 type definitions. So we're not just getting the chemical elements for free here, we're getting 50,000 types for free. Okay, and imagine how long it would take you to write those 50,000 types. So let's take a look at what some of them are. Okay, so here's our IntelliSense list that comes up, and we've got not just some chemistry here. Looks like we've got a class library that contains really a lot of information here. It's all sorts of things, and probably the biggest danger in your contracting job is on the way to actually getting the chemical elements. You actually get distracted and start looking at the comic books or the celebrities or the books, or you might get vain and go down to look for computers and start looking for computer scientists or something, and then it just goes. There are all sorts of hobbies and interests and sports and so on. And if you're into comic books, you might suddenly realize, hey, I don't really want to do my contracting job. I might start to write a phone application, which is all about comic books, and there's probably quite a big market for that. And you can populate it's populated with comic book characters, and then you have all the relationships between these things. That for each comic book character, it will tell you which fictional universe it's a part of, and so on. And then you might think there's another kind of phone application you want to be writing, which might be a baseball application. You can imagine yourself that your job becomes to write an application which, as you go to a baseball game, you take the data feed which has the who's coming up to bat at the current game that you're at, which you can get from the geolocation feed, and combine that with the information here about the baseball players and their statistics, and automatically just visualize the give a sort of running interactive visual commentary for the game as it's progressing. And you can see that as programmers get information, they also get ideas for what they can do with that information. It's one of the things I really like about this feature is it's actually sparking the imagination of the programmer by making putting the information right in your hands. So let's get back to what we're doing. I've taken way more than 30 seconds to do the job. So let's get the chemical elements and show these here. Depending on the quality of our network connection. Now, the first few of these elements coming through are actually ones that haven't been discovered yet, and they have allocated names, evidently, or allocated numerically names. Now, this is quite a complete object model. Each of these is an object we have in a sequence of data coming from Freebase, and it contains quite a lot of information. Well, this is mostly, we don't know about these yet. Down. This is going more data out here. Okay, this is what we're after. So this object model has atomic mass, atomic number, boiling point, and all sorts of things which we probably wouldn't have done in our class library. I wouldn't really have thought of putting electrons per shell in there, though it is pretty fundamental to the elements. And it's got a list of isotopes over here, and so on. Okay. So we don't just want to grab data sets, we want to do strongly typed functional programming over these data sets. So, and perhaps we might need to do some data cleaning as well. So as we start to work with these elements here, so we can get ourselves, let's get ourselves as the first element, which is the head of the list. Now we hover over that, I haven't got it yet, but we know the type here, it's Freebase chemical element data here. Okay. So we haven't actually evaluated that yet, but we're in a strongly typed language, so we know the type of element. That means we know all its properties. So it's got all those properties we were looking at in the grid that are available in our IntelliSense menu. And not only, I mean, the strong typing is not just about getting your program more correct. It's also about giving you nice information as you work with objects. So when we look at boiling point, for example, we get a nice bit of information here about what is the actual definition of boiling point here being used by this particular data source. And one very nice thing you'll notice is that we've been doing recently is as you work with data, you can also propagate units of measure through with that data. So this is actually saying that it's the data is actually in meters here. It actually does a normalization as it imports all the data and converts any length that comes into the system into meters. And that gives you a level. That means, yeah, when you come across a length property or any sort of unit property, you can do the automatic data conversion into a consistent unit system. Okay, so let's start cleaning the data, take the chemical elements. It turns out for some reason that some of these elements don't actually have an atomic number listed, and that seems pretty strange to me, but it shows you how dirty data can be. Even a basic data set like this has some sort of glitch in it where an atomic number isn't listed. So we do actually have to do some filtering, that we want the ones where the atomic number has a value, and we get the value out of those ones, and then we show the grid, and then we have something much closer to the periodic table. And we may not, of course, data, once you have it, takes you in all sorts of directions. Once we added such data richness to F#, we started getting all sorts of requests that we hadn't really got so much before. And one is for a charting library. Okay, as soon as you have data, you need a charting library. .NET 4.0 has a great charting library. So we put together a wrapper over that. It's a 2D charting library. We put a wrapper over it called F# chart, and we just released that on my blog about a month ago, and that's what I'm using here. And F# chart is set up very nicely to work with data, that we can do this functional programming and select out the names and the number of isotopes, and then pipe those into a column chart operator, and similarly we could create a bar chart operator to put the data around the other way, and similarly all the other kinds of charts that are available from the charting library. Okay. So this shows the number of isotopes of the elements as you progress through the periodic table.
So we're fitting all of that.
Okay. Now imagine we had a more complex query. This work is bringing together, when we're working with this data source, we've got the semantic web all the way over here, and we've got programming languages here. We're sort of merging these two things together for this particular data source. There are all sorts of other uses of F# type dividers, but for this particular data source, it's very semantic web oriented. And semantic web people like to talk about queries like, what are the asteroids with the name of a Greek god, for example? And they generally the focus has been on Google-like search, unstructured search, where you just type that into a browser. We're going to take the programmer's approach to this problem, the strongly typed functional programmer's approach to it, where we go through the data source and construct a query which finds those gods. So first of all, we go looking through our data, looking for the gods. So we have religion here, and we have deities here, so we show those, and we've got a set of religious figures coming up. And then we go for each of those deities here. Well, we say, what do we know about the deities? Well, one of the things we know is the religions that worship that deity here. So we iterate through those. And then for each of those religions, we actually just choose out the ones where the name is Greek. The name contains the word Greek here. And then we select the name. And let's take a look at what we get. This can take a little while to run because we're streaming the data down. Okay, so there's some Greek deities. So now we do a similar thing with the asteroids. Let's take a look at those. Now the asteroid names have these numbers in there, so we'll do our word splitting as we saw before, and we'll say split the names. Here's the split version of the names down the right. And now we'll find so we take the list of asteroids and we take the asteroids where the God named intersection between the words in the asteroid name, this asteroid here, intersected with the God names as a count above 0, and that gives us the answer to our query, which is the asteroids with names of Greek gods. Okay, so what you've seen is a form of language integrated web data, just to do the usual thing about showing how you might have to do that today using the same data source using F-sharp 2.0. So we're talking about what's coming in F-sharp 3.0. And it's pretty messy, okay? The ontology there is enormous, okay? It's got 50,000 types, and they're all interlinked, okay? So you can't code generate an API for that data source. So you tend to do this kind of programming where you have a REST API here, that's the underlying service that we're using, and you have a whole lot of network connections, and you get some JSON text, which is just a string, some strings, and you deserialize that into some types, and it's long and it's horrible and it's quite difficult. I mean, relatively speaking, in F-sharp 2.0, it's nicer than in many other settings. You have some great libraries to do this, but compared to what we were just doing, it's obviously an awful lot harder. So the magic here is this type provider mechanism where you can write providers that convert web data, cloud data, or enterprise data into the type system of F-sharp. Type provider is just a design time component that provides a computed space of types and methods. It's a compiler IDE extension, if you like. It's an adapter between data and services and into the .NET type system. So F-sharp doesn't contain any data. It's an open architecture, and you can write your own type provider. So the second example I'll show you is for this Azure Data Market, which is a wonderful new initiative from Microsoft for hosting data, really professionalizing data the provision of data sets on the web. And the professionalization comes in that when you sign in and you register for some data sets, then and you click the terms and conditions for a data set, then there's a service guarantee that comes with the data sets. It usually says something like that the schema won't change for a year, for example. The data service will be available for a year. It's just a basic trend towards the professionalization of data provision. Now, tucked away as you go through these data sets, there'll be a button down in the bottom right-hand corner which says download the C# code to access the data set. And you have to manually put that C# code into your project, and that's how you get your strong typing. Now, it feels like we can do something better than that. So what we would like is something more like what we just saw. So let's load up some background libraries here. Now this is the type provider that we're accessing, the Windows Azure Marketplace Data Market DLL. And what we would like to do is a much more code-focused view of the whole data market. We'd like to be able to go to Windows Azure, go to the data market, look at the data sets in the data market, and just have the data sets available to us here. Okay. The index is available, the schemas to the data sets are available. Why can't we just at least do programming over it? And at some point we might actually have to go and sign up for a data set. I've actually signed up for a couple already. We would like to be able to make the whole process even smoother. The provider then prompts you to sign up for the data set and so on, but I've already signed up for a couple. And there are lots of great data sets here. Some of them are paid for and some of them are free. The ones that actually cost money tend to be the live sporting feeds, the very fresh data, like these ones here, game-by-game scores, live scores of baseball and football. They don't cost a lot of money, but they do cost. They're the ones that tend to be free, tend to be the government-provided ones of demographics and statistics, like these ones here. So we have all FAO data, the greenhouse gas emissions. And every time I come back to this, you're getting more data sets all the time, because more people are hosting data into the data market. And that updates us automatically as we use this particular type provider. So we, for instance, take the crime statistics of the United States. You have to do a little bit more work. You have to take the crime statistics here, and it gives you the information about what is in the data set, extraction of sense, arrest, appearance data, etc. And you have to put this generate tag on here. That just indicates there's actually some real .NET types being generated under the hood. And we create a container for the crime data and then do a query of the city crime information from that data set. And you can see that's the Alaska, the first 100 entries of that data set get streamed out. This is for Alaska in 2007. Now we want to do queries over that data. So for example, so one of the things we're adding to the next version of F# is proper treatment of link queries. So what gets executed here is what gets run on the server. What's in the curly braces here. So this information here gets sent to the server. We want to take the city crime table. We want to take New York in the year 2007. Now it turns out we can't do these parts on the server. We do these locally. So this is where the population is non-zero, where the violent crime is greater than 150, and we map out the city and the violent crime, and we take a column chart of that. Now, I'll change this to Alaska so I don't offend anybody here. Now, it's not normalized by population. Actually, there's only two greater than 150, and if we take reduce down. Additional states. Again, it's not normalized by population. Oh, upwards. Okay. So you can see, just we have, in that situation, we have not just language integrated web data, we have a language integrated data market as well. So we won't necessarily be shipping those providers with F# itself. The set of providers will ship, will be provided in the samples, but the set of providers will ship with the more pragmatic ones with enterprise programming. OData is the standard for web-based or enterprise data streams. It's kind of a weak form of, well, we were using OData then. You can do those kind of queries that I was doing of restricting. You can't join is the main restriction. You can't do join from OData particularly easily. So it's a sort of weak form of web-based data. And Netflix and other sources provide OData feeds. And to embed, we'll be shipping a provider which lets you reference an OData service by just giving the URL, and after that it just does really strongly typed programming against the types provided by the URL. So fluent typed access to OData. Of course, SQL programming. A huge proportion of the jobs in industry have some sort of SQL programming associated with them. So we do a good job of just keeping the connection string, use entity framework or link to SQL to refer to that database, and strongly typed programming against the data sources. So it's a lot like what you get with Visual Studio, with the right-click, make database reference, add service reference, of those elements of Visual Studio 2010, but just a bit more code focused, without all that extra, the extra kind of Visual Studio support that you need to do this work. So we're definitely looking at SharePoint as one potential application. Take a SharePoint site, you just give the URL, and you can start working with the information on the web lists on the SharePoint site directly. This seems, when we show this to SharePoint programmers, it's like, we need this now. This is so useful for us just to be able to do that. And I guess my dream would be that as you walk into an enterprise, that the programming environment is just configured to the data context that's available in that enterprise through mechanisms like this one. Said about adding queries, so you can write this sort of thing for declarative link queries against those data sources. With sort by take, syntactically, where it's as said, what's in the curlies is what's gets run on the server. So things like taking the data is inside the syntax of the F# version of the link queries. Okay, so the vision for type providers is take all this web data, data markets.umi and Active Directory, strongly typed without explicit code gen. There might be some implicit type generation under the hood, but we want it to be extensible and open architecture, and there's all sorts of other interesting data sources to tackle with this kind of work, CRM data or social data. There's no particular reason why you shouldn't have a type for every individual in Facebook, for example, and that each one gets its own type, and then you get to declare your own relations to other entities, and there's no reason why you shouldn't be able to have a form of programming where you have Bill, who wants to program. Well, I want to know what is Joe and Susie and Freddie doing tonight. Where are they tonight? But I definitely don't want to go where Paul is going tonight, something like that. And to write that as a query and have it on your phone. I mean, that's automatically updating all the time. Okay, and SQL data and XML data and so on. So the world is information rich, and our strongly typed languages need to be information rich too. I'm not one to kind of give up and go to dynamic typing just to try and solve this kind of problem. The move towards the dynamically typed languages is largely driven by this information richness, and but I prefer to try and adjust our view of strongly typed languages, perhaps weaken our view of strong typing a little bit. There's always a question of schema change hanging around under this kind of work. But many schemas, many information sources are extremely stable. And so this sort of type provider manifesto is like consume anything directly, strongly typed, and with no walls between you and your data. Okay, so I'll finish up there. So F# is a simple, expressive, productive addition to .NET, ready for use in Visual Studio 2010. It already greatly simplifies parallel and asynchronous programming. And the functional programming is extremely effective, and I think we're augmenting that, combining that with a data-rich future. I sometimes call it information-rich world meets functional programming superhero. And that's what I hope for F# sort of 3.0 is going to go ahead. Okay, there are some books about F#, some of them written by some people in the room here. And depending a little bit on your angle, you can choose if you're scientific programming or functional programming or professional programming. You can choose your entry point into the F# world. There's also some great online books. There's a book called CTO Corner, the F# Survival Guide, which seems very popular for people learning the basics of the language. And there's also a wiki book, which you can help edit and help develop if you like, and that also seems very, very popular. And that's it for me, and we have time for questions, I'm sure.
So, with the type providers, I guess I have two related questions. How much overlap is there with the link to anywhere stuff that Bart DeSmet's working on?
I definitely see it as complementary to that. The link to anywhere is about providing us with lots of link sources, and so is type providers. But you have to. The link is there are two pieces of the puzzle. Okay, once you have link, you can do your queries. Link immediately makes you want to not only be able to link to databases, but start to do link with all sorts of other work, other kind of sources, and that takes you in two directions. One is to get more queryable from places, and the other is to do query-like things over things like event streams and the like. The problem is when you, okay, and that's great, but the problem is when you hit things like Freebase, the one that I was working with, or large database schemas, or as your data market, then you can't use code generation anymore, okay? Because that's still what Link has to use today. it just doesn't scale to the kind of information sources that we really want to work with in those settings. So it's really just augmenting link with this automatic provision of
Okay.
link services. So they're very, very complementary. And I sometimes think of it as Link 2.0. I don't think we haven't particularly got permission to use that name, Link 2.0, but I think it is very, very fitting with the link vision, and we're very complementary.
So, is your vision also to support streaming data, or is it
Yes,
just going to be
yeah, so
numerical
as you
data?
encounter a data source, and then you have to think what sort of container we're going to give back to that data. And it's they can provide observables, you can provide events, you can provide write back, because it's not just about reading, you can write back to these data sources. The .NET information model is an extremely good one for sort of representing the information sources we use. It's got those, one of the things I really like about .NET is it's got these fundamental foundations for the different kinds of things we actually hit in practice. We've got our observables, we've got our sequences, we've got our disposables, and we've got our queries and so on. And these elements then combine in such good ways. Yeah.
Will there be a kind of an offline mode for type providers as far as storing the last data stream?
Yeah, so that we push off a lot of those questions to the design of the particular type provider. And one of the key things is that type providers can take parameters. You saw that here, these parameters here, and these parameters can actually be named as well here. So you'll see parameters like local schema file, for example, equals, and then you get a file name. And that says you store the schema in that file, and then there's a false update, true equals false, which is basically saying use just use the local schema. Don't try and refresh it.
Well, I mean at the data as well. In the case of a classified environment where you don't have a connection to the outside world, but you want to write your program non-classified space and then bring it in. Wouldn't there be a way to store that data feed locally?
Did you want to be able to store it, or is you mentioned classified, or not be able to store it locally?
Well, one way.
Yeah.
But for example, you won't be able to connect to your chemistry database inside a secure area.
Right.
So I don't want the program to break.
Yeah.
When I
yes, you could architect those things in. If you wanted to statically download those data sets and statically incorporate them into your program, effectively, then you could also architect that in. Now that might not come for free from a particular type provider program and as static data. So you could do any of the things we've said. They might come out for free with the type provider you're using, or they might not, depending on what the type provider has, how it has been architected and designed. Yeah.
I got two questions. First one has to do with GUI builder support. We all know that F# doesn't have the GUI builder support into. Any thoughts for 3?
So our plan is to focus on our core mission of analytical engines, and it's augmenting that with data richness, and we get a good direction from the managers and architects at Microsoft about not trying to do what Managed C++ did, which was to try and be like C#, just duplicate everything and make everything work with Managed C++ as well, which probably wasn't the best thing. You should just focus on your core goals. And it's also the client-side programming. You might say GUI builders, right? Yeah, but what about like phone application builders? What about web application builders? What about Xbox, XNA, Game Studio application builders? What about unreleased framework 357 sort of GUI builders? Client-side is a fast-moving space, like anything in computing. And we're very happy with the solution that you do. The client, the user interface, official party line is if you do it in C# or VB, you have an F# backing project. In practice, you can do an awful lot of the client side, the user interface in F#.
Right. Okay, second question is a fairly technical one, perhaps, about type inference. when F# 2 was in beta, I sent you an email asking a question. You were gracious enough to answer briefly, but I'd like to ask the question again now that maybe we get a little more time. I don't remember the details, unfortunately, but basically, as I was teaching myself F#, I wrote a small write to log function or something like that at the top, and because it was used later, I had to do it, put it at the top. But I had to declare the type of the parameter to it, and my email to you basically said, why can't type inference make multiple passes through the source code to deduce that? And you said there were some anomalies that come up when you try to do that.
There's a couple of reasons why we don't do that. I mean, one is quality of error messages goes down with multiple passes. Another is IntelliSense quality goes down. Like, the fact you have left to right then really helps with giving good IntelliSense as you go along, because we have to type check completely incomplete programs. Right? We have to parse and type check very, very fragmentary programs. People still expect a good IntelliSense experience out of that. We've been putting a lot of work into that in the latest, in the last few months. So those things just together. It's the same with link queries, actually. When the C# first did link queries, they put the select first, like in SQL. No, they started with having the select first in their internal design process, and it doesn't work because you don't get IntelliSense as you type the query. So it's a similar kind of. Yeah, at the back.
So it seems like with type providers, there's some kind of code generation going on in the background to give us these types. When does that happen? Is that on compile time, or I see you typing things in and getting IntelliSense immediately?
Yeah. So it depends. There's actually two modes. The type provider can be generative or non-generative. If it's non-generative, then everything gets erased, a bit like dynamic in C#. Just like everything goes down. So they're all just like they're just like types in OCaml and Haskell. They just get thrown away. There's only static types, and they get erased and thrown away at runtime. So it means you can't do type op on those types, or if you do, you get an inaccurate result back from type op.
Do you get IntelliSense?
You get IntelliSense, yes. They're all. It's absolutely, you get everything in static typing, but you just don't get the actual type of the runtime, the system.type objects at runtime for those. The type providers I was using that had the generate tag on them were the ones that actually generate some real .NET types into your assembly. Those types, you can think of them as getting created as you're working with the program and as you compile the program, and then they get put into the assembly. So it's like statically linked into the assembly. Yeah.
I have a question, it kind of relates to the previous question. Let's say I have two types, type A and type B. And type A has a property of type B, and type B has a property of type A. Currently, there's no way to do this in F# because they have to be on top of each other somehow.
Yeah. Yeah.
So in F# 3, are you going to, because this makes object-oriented programming kind of hard in F#?
So no, the object-oriented programming story will stay the same, which is a C#.NET object-oriented programming model. There are some limitations on what you can do with that. I think they're not necessarily killer limitations. There are definitely relationships between types which you can't express in a traditional Java C# object-oriented model. But we decided to rather than kind of playing with or extending the object system through mix-ins, or these were all the various things we were looking at for F# 3.0. We decided to say just keep it steady, there's a lot of simplicity in just going for the same object-oriented model as C#, and we'll focus on populating those objects with type providers instead of like extending the object-oriented programming to try and tackle this.
Well, I'm not talking about extending, I'm just saying
The and keyword, I think.
Because if type A is declared above type B, right?
Oh, so you're just talking about mutually recursive type definitions.
Yeah.
Oh, okay. Yes. No, you just do type A and type B, and then they can relate.
Right, and that doesn't work in F# because it's
No, you can. You just do type and.
Use the and.
Type A and
Okay.
B. Yeah. Sorry, I thought you were talking about other more different relationships between types. But yeah, you just use and to connect the type definitions. Yeah.
Since F-sharp is so good at processing data and so on and so forth, so I was wondering if there's any prototype for doing some kind of an ESP, event stream processing, kind of a sample or demo.
For doing which?
Event stream processing.
Well, in a way, the Twitter's one is a form of that. There are more, especially in the finance industry, there are more advanced sources of events than the ones that I was showing. And events, complex event processing and the like takes on all sorts of other meanings. And Microsoft have products like Stream Insight that you can use with F-sharp to do complex event processing. But I'm not an expert in that field. But any solution you would use for C# for that will work with F#, and there are professional products as well for event processing. But in a broad sense, F# is well set up for doing event processing kind of work, like some of the ones I showed you. Yeah.
So you had in the example, you had I guess it was a class or something like this, or a helper, some kind of event. You also had sequence or something like this, SEQ, something like that, right?
Yep.
They all work on different things. I guess one on events, another one on enumerables. Probably you have something for observable. But you would need different implementation of, let's say, aware, right? For one.
Aware or map or.
Do you have some way of kind of generalizing this?
So, not particularly. You would just use the when you have a computational type like an event stream or observables or so, you have a set of gadgets that come with that type.
Generalize in type class?
You could syntactically generalize the type classes, but you still actually have the different gadgets. Yeah.
This seems really great, and I wish I could use it. But where I find the worst, I guess the most pain in dealing with schemas and interfacing them with external data sources is when the external data sources, their schema is changing over time, and potentially different sources are changing at different rates, and you still have to reconcile all of them.
Yeah.
You mentioned a little bit something about that at the end, but
so the schema changes is difficult, right? Is absolute difficulty in this kind of work, and type providers obviously work very well when you have stable schematized sources like chemical elements or Azure Data Market and so on, and SQL databases and so on. The architecture does include the ability to invalidate the schema that the type inference engine is working on. So the type provider can send an invalidation signal saying, oh, okay, the schema changed, time to retype check the program. And so you does cope with sort of live programming against a schematized data source in that way, where the schema is changing as you work with the data. The type provider might be waiting for a signal from the data source, might be looking for a file change on an event if it's reading the schema from a file, or it might be doing a polling mechanism to check the database every minute or two to see whether or not that has happened. You can architect those into the type providers. Now, of course, there are some programs that have to be truly dynamically adjusting against a schema change that actually aren't really doing statically typed programming against a schema. They're more treating the schema as information itself. The schema is evolving as the program executes. And that is not covered by this mechanism. There are definitely some places where dynamic program property bag techniques and the non-statically typed techniques still apply. The program doesn't make everything static.
Don, can you leverage .NET versioning support for, let's say like this version of DLL works with specific version of service? Now, if you want to change it, you will just reference another version and change URL? That would be up to the provider to decide that they would take, label its data as version information. Problem is using the .NET versioning scheme as a way of kind of taming
the evolution of arbitrary information in the outside world I don't think that's necessarily a good fit. It's quite a good versioning scheme, but I don't think it's a one-size-fits-all. If you take Freebase, for example, you can give Freebase a parameter that says, I want to look at Freebase as it was at a particular date. And I ignore any data changes after that, any schema changes after that, but at least I can pin down the whole thing and say, nail it down, and we're going to keep it stable. So that's, versioning is a complex topic, and different data sources have different versioning kind of characteristics, and you would expect to see those reflected up through the type provider. So like, you pass in a parameter saying Freebase at this date, please.
I know you said there's no CTP available now, but any estimate as to when we might see one?
Oh, we're working pretty hard. I was working pretty hard last week, so this side of it.
The technical architecture open and flexible enough to provide either plug into or wrap to provide for cross-functional things like normalization and logging.
Could you sort of do some AOP kind of thing and put some memorization log? Yeah, you can do that. Something like I put in that unit conversion so that all the numbers coming out of Freebase would get automatically converted into meters, even if they were labeled as picometers in the database or whatever. So you can. I mean, we certainly don't position it as an all-purpose AOP kind of thing. We wouldn't. So we wouldn't typically expect. In particular, there are some limitations on the types that can be provided. We don't actually allow you to provide generic types. You might be surprised considering my involvement in generics, which shows you we're really orienting it at these information spaces rather than arbitrary sort of programs or transformations of .NET DLLs. Where there are reasons why we make those limitations. Providing the types, it's relatively easy to write these providers. We can have a look at some of them, the drinks afterwards on the laptop if you like, but I'll show you the one provided here, WMI. WMI is, anybody who does management, PowerShell programming will be familiar with it. It's just all the information available on your local machine about, or on your system network. Systems programmers, system administrators use this all the time for, say, PowerShell. And by giving a WMI provider to say, let's look at all the batteries on the machine, or let's look at all the whatever else, CD-ROM drives and everything else, and you can do this over the machines on your network, and it's all the information that's on your machine. This provider is only like 150 lines of code, or something. It's a relatively simple transformation of the information space into the .NET type system, now I've forgotten the question. What was the original question again?
It was just saying like whether you could plug in some type of orthogonal concern into like the type provider.
Yeah, and I was saying we don't support generics. Yeah, so writing the providers is relatively easy, but it's still possible to get some things wrong, and the more complex the entities that you can provide, the more chance you can get things wrong. And we kind of don't want to expose everybody to the full complexity of providing, say, .NET generics through these types, so we decided to come
So like this is pretty good for doing like you showed, like for async and parallel and so on, right? So now, any thoughts of like going forward down the road, perhaps doing like multi-node and multi-machine kind of environment where you provide some support for that?
So distributed with programming frameworks and the like. So that is, there's various other groups. We see that as a responsibility of other groups at Microsoft to solve to provide various distributed programming solutions. Azure being a major initiative at the moment, HPC computing, and so we don't see that as a core F# responsibility. It's more take F# and combine it with HPC. Take F#, combine it with Azure. Okay,
so like in terms of like tooling and like not from an environment perspective, but from a tooling and coding and programming perspective.
Yeah, well, those people also provide a whole lot of programming tools. Okay, so when you do Azure programming, you get a lot of programming tools with it, and you can use those with F#. Right? So it's again take those keep the concerns separate, take that programming environment, combine it with F#. And people, and then, if necessary, do a little bit of work to make those idioms into F# idioms, like these F# agents in the context of Azure, for example. So we do ask people to put the pieces together on the distributed programming side, rather than trying to create a one-size-fits-all, because there are many different manifestations of distributed computing. Yeah.
Is there a way we can access the metadata of path providers in a quick way, like probably non-reflection?
You just load up, the type provider is just a DLL, and you define an object, and you just load up an instance and run. You can actually use the type provider, right? With the F# compiler, it's just creating an object that's an instance of the type provider. You can do the same thing with your code. So yes, you can access the metadata. You can do what the F# compiler is doing to access the metadata.
Was there a question about runtime? Reflection is reflection at runtime, maybe?
Yeah, at runtime. So at runtime you can do what the F# compiler is doing, and just create an instance of the provider and let's use it. Yeah, we don't. That's not what the mechanism is sort of for, but it's dead easy to do. Yeah.
And this may be like old question, but I was wondering, the actor model in the Axum project. What's the status of that, and where do you see that going forward?
Yeah. So F# has the in-memory agent model. So the question is again about distributed. It's more or less the same answer in a way.
But on the similar scale, like it's like somewhat more towards away from async and parallel to more like concurrent and things like that.
So we have a good in-memory actor model in F# today. It's not an isolated model. It's a key question it is a key question for this class of languages like C#, Scala, F#, about getting a notion of isolation into the languages. It is definitely something we've talked a lot about as being, and it was one of the things we were looking at doing in F# 3.0, but we decided to solve the data problem first. But it's definitely putting isolation in and sort of distributed frameworks is absolutely something we are interested in. We would need, because it's kind of getting outside the languages realm into the systems realm, we would need the right synergy with the other team, with another team at Microsoft to create an overall framework.
Is Axum still part of like the F# team, or is it like a separate team?
Axum wasn't part of the F# team. It's an incubation which is not continuing at the moment. It's certainly very, very influential in incubation, very successful, I think. In this game, you have to get used to the fact that your success is as much about having influence as anything. Like F# has had a lot of influence on C# and VB and the async models and many other things. And the same with Axum has had a lot of influence on the same things. And so, yeah. What do you have in mind for 4.0? I think we've touched on some of the topics, but there's loads of great things we could be doing. There's also a load of work we need to do on the Visual Studio tooling. We do know that the experience of using F# in Visual Studio compared to the C# experience is raw in some ways. That some things don't work with F#. F#, I think that's okay given the role of F# in this core analytical engine, but we could easily spend a whole product cycle doing nothing but Visual Studio tooling for F#. When you think about how much we put into the language of F#, how much power, then we do have to balance that with this great Visual Studio tooling. The tooling is pretty good for this class of language, but we could C# and tools like ReSharper and the other tools for C# set a very high standard of tooling. And,
just the rename and that's it.
Rename, yes, that's one.
All reflector in it.
One beer at the pub at least for rename. I'll start selling off features. Let's say 2 more questions. Yeah.
Will these types be consumable in C#?
In C#, at the boundary of the DLL, you will if they were generated types, you'll see the types. If they were what we call arrays types, then you'll see just like system.object, or you'll see some or system.freebase object, or system.database object, or some base type, some erasure at the time. Yeah. Okay, 3 more. Well, we should head off. So we'll take these three more questions, and then.
Just going back to type providers, would it be useful to feedback your analysis of the program into your type generation so that you can do something like generate the absolute smallest type you need to avoid downloading information?
Yes.
What do you do with that?
Good idea. Yes. So type providers open up all sorts of interesting questions, right? And that's one I haven't heard asked before. You can't do that in our architecture, but I think it's not unreasonable to have a more complex dance between the program and the type provider. There's another limitation on type providers, which is that you can't pass a type you've defined to the type provider. In F-sharp 3.0, it's something a limitation we'd like to lift in a future release. But that is a powerful thing that lets you do all sorts of type-directed programming, metaprogramming in the type provider. So, but it means there's a more complex dance between the type provider and the compiler.
If I found a type that hasn't been captured by type repository type providers, is there a business model where a single developer can capture that type, capture that data set, and be able to actually make money off that?
What, to publish a type provider? Yeah, I think there's will be an industry for people providing type providers. Yeah, whether that's a cottage industry, an open source industry, or it's a supply-demand thing as well. So yes, there could. I can see there being a demand for people just having a type provider which connects them to a data source, especially if that people who are demanding that have money to pay for it, and the data source is of high value. So you have to choose and the people not only have money but are used to actually handing their money over. Well, final question of you.
Yeah, Don, you compared with Python with F-sharp sometimes. How does it compare with Mathematica?
How does F-sharp compare with Mathematica? Yeah. So Mathematica is much more oriented around symbolic programming. That there's you create. You have. I mean, it's always doing these symbolic expressions and doing reductions and simplifications on those symbolic expressions. There is some similarity, and it's and they're both mathematically oriented languages, but I think the experience of using the two is pretty different. The Mathematica has that very nice system of writing a script, writing a mathematical document. It's a very document-oriented thing. We have some of that in F-sharp scripting, but certainly not to the extent of Mathematica. So F-sharp is just much more oriented towards the programming part of that spectrum. You probably do have to think of yourself as being a programmer. You may be a quant programmer, or you may be a scientific programmer, but the F-sharp user will normally think of themselves as being a programmer, some domain specialist programmer.
But could you pick up some of this artifact from Mathematica?
Yes, I think you could combine those, and yes, we could add feature requests to say, we would do the document style editing for F-sharp, and there's sort of a spectrum between that and spreadsheets as well, and you can see some of that in some of the projects based around Iron Python. There's one called Resolver, I think, which is an Iron Python based spreadsheet, which is quite nice, and again, we chose to place our bets in different places, but in principle, yes, but it's there is a lot of engineering behind those kind of tools, and you have to have, enough engineering that you probably have to be creating a full pay-for product. Okay, F-sharp is a programming language that we do give away, we can use it for free, you can buy it in Visual Studio and so on, but it's not in itself a full pay-for product. We don't want it to be out of philosophical reasons. Okay, so thanks very much for having me.
He's forgetting all that.